Have you ever stopped and wondered how scientists actually do it? How they go from just looking at, say, a simple plant to a discovery that completely changes the world? Well, it's not magic. Not at all. It's actually a really powerful but simple way of thinking that, honestly, anyone can use. And today, we're going to break down that exact logic, starting with something you've seen 1,000 times, but probably never thought of as a scientific tool.
You know, everything really does start with a good question. And for us, our whole mystery begins right here, with a simple, moving shadow. Now, this isn't just a patch of darkness on the ground. Think of it like a clue. It's our first piece of evidence in a much bigger investigation into how the world works. So let's put on our detective hats for a minute and see what this one little clue can tell us.
Okay, so the first rule of any good investigation, any good detective work, is knowing the difference between the hard evidence and your theory about what that evidence means. In the world of science, we call this separating your clues from your hunches, and believe me, this is the absolute foundation of thinking clearly about anything. Let's really break this down. On one side, you've got your observation. That's the clue. It's a fact you can't really argue with, like the ground is wet. But on the other side, you've got the inference. That's your hunch. It's the story you tell yourself to explain the clue, like, it must have rained. See the difference? An observation is what you know, and an inference is what you think it means. So let's get super precise for a second. An observation is just pure information you gather with your senses. No guesswork. So looking at our shadow, a pure observation would be something like, at 9 a.m., the shadow of that flagpole is long and it's pointing to the west. That's it. Just a statement of fact. This is the bedrock, the solid ground that everything else gets built on. All right, now that we have that solid observation, we can make an inference. This is where we take our logical leap. If the shadow is pointing west, well, it stands to reason that the light source has to be coming from the opposite direction, right? So our inference is, the sun must be in the eastern part of the sky. We just built a whole story from one little clue. Okay. So a good hunch, a really strong inference, does more than just explain what you've already seen. Its real power, the amazing thing it lets you do, is predict the future. It allows you to make a bold, testable forecast about what's going to happen next. Just look at how this chain of logic builds on itself. We start with another observation. Hey, the shadow isn't just sitting there, it's getting shorter and it's moving. From that, we infer a much bigger idea. The sun must be moving in an arc across the sky. And see, that powerful inference lets us make a really specific prediction. Therefore, in 1 hour, that shadow is going to be even shorter and it'll be in a new spot. We just went from watching to reasoning to forecasting. And this right here is the key thing that separates real science from just, guessing. A scientific prediction can't be all vague and wishy-washy. It has to be so specific that you can prove it right or prove it wrong. You got to put your theory on the line. Just saying the shadow will change doesn't count. But saying in 1 hour it will be shorter, now that is something we can actually test. So, we've observed the clues, we've inferred our theory, and we've made our bold prediction. What's next? Well, now comes the moment of truth. This is the part where we stop thinking and we start doing. We're going to run a little experiment to see if reality actually matches up with our prediction. And an experiment can be super simple. You don't need a fancy lab for this. At 9 a.m., you go out and you mark the tip of the shadow. Then, based on how it's been moving, you put another marker down where you predict the tip will be at 11 a.m. And then, you wait. At 11, you go back and check. You make a new observation. Did the shadow's tip land on your marker? This is it. This is how you test your idea against the real world. And if it does, what if that shadow lands right where you said it would? That moment, that's called validation. It's this incredible aha feeling where your new evidence, your new observation, confirms your theory. Now, it doesn't mean you're 100% right forever, but it for sure means your inference is strong and you are definitely on the right track. So this might seem like a fun little exercise with a shadow in your backyard, but what is truly amazing, and I mean this, is that this exact same mental toolkit, this is what's responsible for some of the biggest, most world-changing breakthroughs in the history of science. Seriously, think about it for a second. Isaac Newton observed an apple falling and the moon staying in orbit, and from that, he inferred a universal law of gravity. Charles Darwin observed that the finches on different islands had unique beaks, and he inferred the entire theory of evolution. Scientists saw similar fossils on continents thousands of miles apart and inferred that they must have all been connected once. It's the same pattern: observe, infer, predict, just applied to bigger and bigger mysteries.
So here's the crucial point, the real takeaway. This isn't just some science thing. This is a fundamental way of learning about the world. It's a system, a process for turning a simple, I wonder why, into a solid, tested understanding. It's how we transform our own curiosity into real, reliable knowledge.
If you only take one thing away from this, let it be this 4-step loop. First, you observe the world around you. Then, you infer an explanation for what you see. You use that inference to predict what's going to happen next. And finally, you test that prediction with a brand new observation. That simple cycle right there, that's the engine of discovery.
So now, this toolkit is yours. That same logic that traced the path of the sun, that uncovered gravity and evolution, it's something you can use every single day. So look around you. Find your own moving shadow, your own little mystery. What will you observe, and what will you discover?